Great. So hello everyone and welcome to a new circular economy webinar from ERASME. Today it's my pleasure to introduce Manuel Morales. He's a researcher at the ERA chair team at Inforact at the School of Economics and Business in the Kaunas University of Technology. And he is also a dear member of the executive board at the ERASME Excellence Center for Sustainability in France. He holds a PhD in economics from Université Clermont-Auvergne and a postdoc at the Industrial Bioeconomy Chair in Neoma Business School. He has scientific interest in sustainability. Sorry, there's a cat playing in the background. He has scientific interest in sustainability, industrial economy, circular economy, natural resource management, and environmental engineering, applying multi-layer modeling, network analysis, and system dynamics as a methodology to simulate future desirable scenarios. He's a member of the International Society for Industrial Ecology and French Regional Studies Association. Manuel is also a guest editor at the journal Sustainability for a special issue on circular economy strategies in the industrial activities, synergies and trade-offs between sustainable development goals. So with that being said, we will present today on rethinking sustainability in the circular economy, challenging socioeconomic models in the industry 4.0. So Manuel, the floor is yours. Thanks so much for taking the time to present, and I'll get back after your presentation to moderate the discussion.
Thank you. Thank you so much, Ed, for this complete, very warm introduction. I'm really happy to be here to share an exchange with all of you. So let's get into this topic. So as Ed just mentioned, I just moved to Lithuania into a research group that is focused on the industry 4.0, and I'm the researcher that is in the specialist in circular economy. So as I'm going to mention or to introduce in this presentation, I'm working. It's an ongoing work about the development of a macro scale methodology in order to better assess sustainability in the circular economy. So I'm not intending here to give a breakthrough lecture. I'm rather trying to attract academic interest over this specific topic, this macro scale evaluation of the sustainability in circular economy, how this could help in order to develop an entire framework, a regional framework, at least in Europe, where I'm trying to start this regarding sustainability in circular economy. So I'm going to talk during these 4 minutes about the limitations of the circular economy, but also the scopes and how all this framework could be incorporated in the European guidelines. So let's go to the next slide. So here we have an overview about what I'm going to talk on these 40 minutes. So some bullet points, the anchor concepts that I think that are really necessary to better understand what Industry 4.0 is, what circular economy, what's the understanding of circular economy that we are taking into my specific study, and also how sustainability is linked or is assessed into the circular economy framework. Again, some limitations, what are the challenges in developing this 5 steps methodology to assess sustainability in circular economy, the discussions, of course, conclusions, and also exploring synergies. So I want to present the the study that I'm doing now, how could be also, if interested, people could be interested in joining. It's also, I'm also open to discussion. So let's start with those two bullet points. Uh, I want to make, of course, two claims. The first one is that circular economy may not deliver sustainability if circularity leads to increase in material and energy consumption. Could be, it's not possible. So, and the second claim that I want to make is that we should consider that with great news, because the acknowledgement of 100% circularity is impossible means that we can reinvent this new sustainable model, and this could not be understood without the means that the Industry 4.0 could supply. What are those means? Means like digitalization, automation, artificial intelligence, smart production and consumption, among others. In this figure, if you can see it because it's a bit small, you can see that in general in Europe we are only using 12% of recycling material inputs in 2019. Materials like plastic, metals, biomass, and also fossil fuel products or byproducts. So it's really marginal, if we can say that, regarding the 100% of waste. The 12% of recycling is not enough, but we cannot just depend on recycling. And here we are going to give some arguments regarding the limitations that we have in recycling in our framework. Okay, so let's start by defining these three concepts that are really necessary if we want to understand better what we are where we're going with these challenges or with these goals. First of all, Industry 4.0 is started like 10 years ago, or a bit more, like 15 years ago, as a framework that was addressed to in the manufacturing industries to better develop more smart manufacturing in production, but also in consumption. Those links in the value chains, of course, in the supply chains, that could be on real time, thanks to different technologies that were available or that are available nowadays. Technologies like digitalization, automation, virtual intelligence, artificial intelligence, virtual reality, sorry. So those all those technologies were also evolving, and the conceptualization of Industry 4.0 has also been strongly adapted to our real needs in Europe, but also in the entire world. And nowadays, it's more the understanding is more abroad. It's not only limited to the manufacturing industry, so it it concerns almost every industry that exists, and the main objective, the main aim, is to involve digital transformation for the entire industrial and consumer markets. So this could be or has and also has been incorporated in many public strategies. in many countries, starting from Germany. So also it has also been developed in South in Asian economies like South Korea and China also. But also this industry 4.0 is really and could be also linked, strongly linked with circular economy, and this is one of the challenges that emerged during the development of my research in this research center in Lithuania. So just to be clear also about circular economy, circular economy, as all of you know, because this is a circular economy webinar. Circular economy, it's more it's concerned the minimization and the adoption of cleaner technologies while maintaining the value of products, materials, and resources in the economy for as long as possible. It concerns not only the closing of the loops, but also to get more intensive use of these loops and to, to get along yeah, more lifetime to the product that we are creating through eco design, recycling, and so on. So the three air principles are also linked to this, to the better use of the resources in circular economy. These three R's principle is reduce, reuse, and recycle. Okay, next slide. Okay, finally, the third concept that it's really necessary to clarify, it's sustainability. How sustainability is linked to the circular economy framework. We start by defining sustainability, taking into account two main sources, because as you know, sustainability can have many different definitions and understanding according to the defined goals. But here in this in my studies, we were linked mainly to sources to better understand sustainability. The first one is sustainability are defined in the Sustainable Development Goals that were settled by the United Nations in 2015, which supply a set of indicators that facilitate the tracking of sustainability in a macro level. So we know that they propose 17 different goals, and the most linked or the closer with circular economy, according with the literature review, are goal 7 and goal 12. So the goal 7 that concerns affordable and clean energy, and the goal 12 that is responsible, that addresses responsible production and consumption. So both are identified as with the strongest links with the circular economy. But also we're trying to incorporate another source of frame for framing sustainability, that is the strong sustainability paradigm, that is based specifically on the non-substitutability, or at least not perfect substitutability, between natural and human-related capital. So, I mean, the central aim of strong sustainability is to protect this natural capital in order to avoid the risk for planetary boundaries. Okay, once identified that, we need also to better understand the challenges that we're going to be described in the next slide. We all need to be aware that the circular economy has some limitations. It's not the perfect or the miracle solution for sustainability. It's a strategy that needs to be incorporated with many others, specifically trying to reduce the consumption of inputs or raw materials and energy that are getting into the flow of the production and consumption. But here are the six main limitations that we identified, also analyzing the literature review that it's available. The first one, it's energy carriers. It means that there are some biophysical limitations. So, mm, I mean, when we are using materials and products, there are some residuals used that doesn't doesn't allow 100%. Technically, it's not possible to recycle 100% because of the laws of the thermodynamics. That is energy dissipation when when material and energy are changing from one stand to another, from one state to another. The second limitation, it regards temporal system boundaries. So this could be classified in product durability and the product's lifetime in the economy. The first one is really it's a well-known limit, because we know that the most the material and the product la- last in the economy, the better is for the economy, because we doesn't need to replace those for many times. But it also has some limitations, because we have now many unknown uh, consequences that could be a risk for the human health, and also for the nature. For example, we have the example of asbestos. It means that 30 or 40 years ago, many of construction projects were developed using asbestos, because we were not aware of the harmful effects that this asbestos had in the human health. But now we are aware. It doesn't mean that now we are using a lot of new molecules and products and elements. It doesn't mean that in 10 years or in 20 years, we're going to get aware of some unattended effects. So this is also something that needs to be taken into account. And the second category is the product's lifetime. This is important, specifically for products and materials that has long lifetime in the economy. More specifically, we're talking here about construction. Most of materials that are used in construction needs to take into account the lifetime in the economy. And many studies have confirmed that rates above 1% per year in those kind of products destined to construction just counteract the recycling benefits. So if we want to really get or approach into a circular production and consumption in construction, we need to be below the threshold of sustainability that gives in average it's 1% increase per year. Otherwise, the benefits from recycling are just canceled from this analysis, because more than we can see here in the blue line. It is an increase of 2.5% per year in copper, and this means that it's much more than above the sustainability threshold, because with a recycling rate of 60% for copper in 40 years, we are just tripled the production of copper from 1975 to 2015. So it's canceling the benefits from recycling completely. And in the red line, we can appreciate an increase of 1%. So this is right below the sustainability threshold for copper. Okay, so we can say that it only applies for construction products, for products that keep in the economy for a long time. But this is really important because almost 60% of all the waste that we are producing in developing countries, in Europe at least, came from construction. So this represents a big issue for society in general. For the last limitation, and you're going to go faster there. It's the first one is the spatial system boundaries. It's complicated to identify the overall sustainability in a project if we are taking some decisions in the local region, but they are generating some negative trade-offs abroad. So this kind of limitation is difficult to take these special boundaries into account, because usually we only evaluate the impacts that we can see in some projects. Number 4 is the limits posed by the fiscal economic growth, and this is the rebound effect in general. So we all know that the rebound effect is this relationship that exists with an increase in the eco-efficiency that impacts also the triggers an increase also in the consumption because of benefits emerging in the price is coming from the eco-efficiency. Number 5 is path dependencies. Here you can say that even when we are economically, ecologically, and socially better, some new technologies, the established structures resist to changes. So the economic and business logics of path dependency may prevent many of the suggested circular economy innovations in this Industry 4.0 from penetrating the markets. And the number 6 is the changing concept and the dynamic concept of waste. So what is waste here doesn't mean that it's going to be waste everywhere else. And also regarding the time frame, what it's waste now doesn't mean that it's going to be waste tomorrow. Okay, so let's go to the challenges. The specific challenge regarding the circular economy in a macro scale. Let us, when we acknowledge that we have limits in circular economy, we need to be aware that society needs some tools that are able to recognize those trade-offs and also to identify and maximize synergies to better approach or to better accomplish a sustainable transition. And in order to do that, we need to assess, or we need to have a method to have a better understanding of sustainability in a macro scale in order to address those limitations that we already identified. So here is one of the, the methodology that the 5 steps method that I'm using in order to approach this challenge. And we claim here that a comprehensive approach that integrates into a macro scale could integrate some micro and meso indicators, could develop a better understanding that could be embedded into a territorial behavior of the actors that are engaged in those systemic behaviors. So each region should and could be taken case by case, because what is sustainable here in Lithuania it's not maybe in France or in Sweden. We have different structural behaviors that gonna influence the impact and the drivers that needs to be encouraged and fostered. So five different steps are going to help us to move through this micro analysis. First of all, is the goals screening, and then we create regarding some case studies, we can identify the most representative cases in a specific territory or region, and then get into a structural behavior or dynamic behavior understanding through a stock and flow system modeling. Then once we have those models, we can go through a cross impact analysis. The number are changed there, but it doesn't matter. The fourth step is a micro level sustainability diagram that's gonna help us to approach into a micro regional framework. And finally, thanks to that, we can also go into public recommendation, public strategy recommendation regarding the specific conditions and context to make some interventions, public interventions. So, as I told before, the first step is identifying the goals. And here, according to our method, we identify 8 different goals. It's necessary to highlight that these 8 goals are the goals linked with sustainability and circular economy. So in this relationship, in this trying to merge all those 2 frameworks, we identify these eight goals. What are those goals? For circular economy, we identify how to close and extend loops, how to extend product life, how to tap into underused capacity. This is sharing economy, alternative use of products and materials. And regarding sustainability, we identify five goals in the framework that are coming from sustainable development goals, but also from a strong sustainability paradigm. What are those goals? It's renewable energy, energy efficiency, waste generation, how to get a greater diversity and therefore increase resilience, but also addressing ecosystem function. So those are the 8 goals that we previously identified. And then, of course, as I mentioned before, we need to have a structural, systemic understanding of the case studies that are not selected by luck. I mean, those are really representative from the most important sectors in those economies in France, in this example. So to better represent systems complexity, we use here system dynamics. And here in this, for those who are not well familiar with system dynamics, we define causal links between actors and their dynamic behaviors, and then we attempt to have a better understanding of a resource allocation. This methodology also helps to visualize the impact of the decisions that we take in the model in order to simulate the stocks and the flows in the medium and long term. For this specific example, we use a modeling of the biorefinery that is located in Pomaco-Bassancourt in France, in the Grand East department. So we take data from 10 years, from 2007 till 2017, and then using this data, we run 3 different scenarios for the next 10 years. So we have this simulation from 2017 to 2027. I mean, it's a methodology that could address long-term simulations. Okay. So just to clarify here, it's a sugar beet. Here we have a main discussion in between the actors. Sugar beet is going to be used to produce sugar, or sugar beet in this case is going to be destined to produce bioethanol. This is like the crucial allocation of these resources, with the many implications in the system for each decision that I'm going to talk in the last slide. So okay, those are models that could give us a lot of information from the structural behavior of the actors that are implicated in the system, not only regarding stocks and flows, because it's the main criticisms that we stay only in stocks and flows, but once we know what are the drivers, what are the main fluctuations in the system, we can also calculate the market prices and the benefits from each decision that take place in the system. Okay, the third step, it's once we identify the objectives that we are going to address, and once we already develop the systems modeling, we're going to cross impact analysis, because we already know better the systems that we are decrypting, that we are analyzing. And here in this specific case, in Pomaco biorefinery, we identified some contracting relationships in between the different goals. Don't pay attention to the red the red circles because it moved in the during the format when I changed. So the three red circles should be in renewable energy, diversity, and ecosystems functioning. So it means that in this specific case, in the biorefineries, that it's located in bio-based economy in France, we have a problem that when we change allocation decision to send all the biomass or most of the biomass to produce bioethanol, it impacts in the byproduct production. So, for example, in this biorefinery, we have an entire ecosystem that is living from the byproduct that is producing the main refinery, the main biorefinery. Byproducts like CO2 because they are producing carbonized drinking from sodas uh, through Air Liquide, so another company, really high-tech company. But also they are producing fertilizers. They are using the byproducts of the black liquor and taking the rest of the waste from the sugar. It's also incorporated into the production of alcohol for non-aliment non-food purposes. So they give to that byproduct a higher added value. So this is the real trade-off in those cases. So we destiny all or almost all our biomass to the bioethanol production, and we are uh, taking away the necessary inputs that all those high-tech industries that are living around the biorefinery needs to persist, to endure, to get some sustainability in the ecosystem, or we just decide to go through the bioeconomy transition that tell us that the renewable energy should be privileged over the all the others. So and this is a specific situation. It's not the same for other case studies that we have already also studied in France. Also, the case of Dunkirk, that it's located in a seaport location in the north of France. It's different. So we can identify some similarities and also some differences, structural differences, thanks to the structural analysis of system dynamics of the stocks and flow. And thanks to these differences and similarities, we can create a micro level guidelines or framework for sustainability in the circular economy for France. So this is a visual picture of a CLD. CLD, it's a causal loop diagram. For example, here we can see with the arrows that those arrows are connected and represent causal relationships with a sign that it's plus or minus regarding the relation, if those are reinforcing loops or those are balancing loops. Okay. Well, but when we develop this framework, we go through the last step of this method that I'm working with. That is the proposed leverage points and interventions. So here, once we identify two different case studies that had been analyzed through the structural behavior of the actuals in a dynamic way, in a system dynamic way, we can then identify two different clusters, at least in France. So those clusters are different for a bio-based ecosystem, which is the case of the biorefinery. It's different from a ecosystem that's located in a seaport like Dunkirk. In the first cluster, we can identify the strategy, the most recommended strategy is to potentialize the synergies, encouraging the product innovation. And how? Here is where Industry 4.0 could take an interesting place because of manufacturing, automation, digitalization, in order to reduce this material use, this biophysical use of the product, could replace the the needs for profit. So even when we are reducing the material, we could get some strategies in order to help those companies to stay in a profitable number. So then also here, a renewable strategy, the renewable energy strategy, is also desirable. So we can encourage in, sorry, yeah, we're talking here about the Dunkirk. So in Dunkirk, also renewable energy transition, it's desirable, which is not the case, at least in a strong way in the biorefinery, but also on a waste reduction strategy. It's also something that it's not counterproductive. It doesn't counteract all the other strategies. So those three strategies could be in line, and as we already see in the cross impact metrics. And the second cluster that is more linked with the bio-based economy in the biorefinery, it's encouraging the biodiversity. We need to take into account resilience of all the different firms that are taking they're taking benefits from the byproducts and the waste that is produces in this ecosystem. Finally, I think it's also time to leave some time for discussion. It's we need to be aware of the importance of some micro level analysis because usually scholars just stay in the micro or meso level of discussion, and in order to get a better understanding of sustainability and the net global trade-offs of sustainability, we need to encourage the discussion in this upper level of analysis. And also, this is something that is important to highlight, that the stakeholders' participation in some kind of general guidelines, because those could be translated in public strategies, in public strategical clusters, also give ownership to the projects. So when stakeholders get engaged in the discussions and can see the different steps of the methodology that help into the understanding of the systemic approach, it also generates good outcomes out of those participation. So finally, just well, because I talked in the beginning about the European framework, and I only give an example of France with Dunkirk and the biorefinery in Pomaco. I can also say that I have already made some preliminary studies in Sweden, in Lund, that are going to be also incorporated into this general framework. cover Northern Europe. And I have also a case study in Lithuania that's gonna take place very soon, I hope, with the continental tires network in here in Kaunas city. But I have also some contacts in Spain that I'm trying to get something from a case study in this south part, maybe Italy, Spain, I'm not sure, but I'm trying to get information from all those case studies in order to translate that into a more general framework in a macro level for Europe. So that's all from my side. Thank you so much, and I hope that you have found that interesting and make some. Let the floor for some questions in case you have.
Thank you so much, Manuel. Very insightful presentation that you gave us. And yes, there was a question from Arno, and he was asking whether you think that price of raw materials and waste are still important leverage points in circular economy, because now we have climate change and ecological footprint that seem to cover more biophysical flows and stocks. So whether we need more resilient strategies rather than efficiency strategies. So in a way, companies would need more scenarios and dynamic modeling on global effects to redesign their circular strategy. What are your thoughts on that?
Yeah, I completely agree. I think that we need some resilience strategies, but I'm quite skeptical in order to also say that the miracle solution is going to be to completely uh, made a shift into a resilience strategies and also forget about all the rest. So that's why I think that it's really necessary to study the context, the territorial context in each region in order to get what's the better strategy to take in in public policies, interpretation of the context and the systemic structural behaviors that could better impact the the final outcome that we are looking for, that it's a sustainable society in general.
Thank you. And there's a question from Vincent. He asks whether you think it will be possible to connect circularity with sustainability through linking circular metrics together with life cycle analysis metrics.
Of course, I think, I mean, I made all my work based on the assumption that a good proxy to understand the dynamics of a territory, of a region, is through the stocks and flows dynamics. So of course, the materials and the energy behavior are relevant. And I think the LCA analysis, LCA metrics are really relevant tools to get a better outlook of how the region, how the territory that we are analyzing, it's evolving over the time.
Indeed, it was, in that perspective, when we come about metrics and you're using system dynamics modeling, I really like that you're doing that and you're using both qualitative and quantitative system dynamics methods. So that'll be really interesting to see what results come out of your project, because I think that's a great tool for integrated assessment. But building on that, it has been argued that circular economy is kind of missing on the social aspect of sustainability. So how would you also, because we're talking about socioeconomic, but we seem to focus on the economic rather than the social. So how would you think circular economy could contribute to really achieving sustainability more into the social sphere? And how do you think this can be assessed? And would you say that with the tools that you're using now, specifically system dynamics modeling, you'll be able to assess that too?
Yeah, that's a really good question, and really, I mean, I cannot give a full answer. I can give my thoughts on that. But I think that circular economy, that I'm agree with you, has a lot of criticisms regarding the lack of social dimension. And this is mainly from my point of view because the tools and the indicators that have been used for circular economy are linked to the micro scale of analysis. I mean, you're you're evaluating the recycling rate of a specific industry or in a specific sector, and those are really isolated, if you can say it like that, isolated regard of what is happening. And the best case scenario, we're also trying to analyze an ecosystem, an industrial ecosystem. But it's again, this is a meso scale that it's only trying to see how within this ecosystem the synergies are taking place regarding the exchange of flows and energy, and if it's really helping the final outcome, if it's environmentally beneficial for the collectivity. But we are not taking into account the upper level of sustainability that really engage society. I mean, if we want to consider the this societal dimension of circular economy, we need to go into an upper dimension that helps to a micro analysis of the entire framework of this strategy. Again, this is not a miracle solution because a lot of trade-offs emerge, pop up when you're trying to fix one hole, then another hole is gonna appear. But taking into account a micro scale, with a micro scale analysis, we can also identify that one hole that has been covered here in my city, it's gonna yeah, raise another issue abroad. Um, with the current tools that we have available, this is really difficult to identify nowadays.
Mm. Yes, and building on these tools and the methodology, Arno asks if you believe that participatory modeling, so involving stakeholders in circular economy strategies, could improve the benefits of circularity.
Of course, I'm fully convinced of this. I think you cannot develop a fruitful recommendation in public policy if you don't engage uh, public actors and also stakeholders into the decision level. That's also why uh, the cross impact matrix that I included in this method is just before we have developed this system model. Is the system dynamic model, because in order to create this model in a precise and coherent way, we need to involve all the actors that are participating in the territory. So all the information needs to come from the real actors that are that are taking place in the territory. So all this information is necessary. And also, as I say, I think that these participatory processes helps to get some ownership of the outcomes. So once the actors understand the logic behind this systems modeling, then it's easier to get engaged and to attempt some social level indicators, because otherwise it's hard to let people understand that what we are doing is gonna help somebody else in abroad, but you never know who is he or her, or even if we are talking about the time frames. So you're trying to explain uh, somebody in a company that the decisions that you're taking now gonna gonna bring some benefits, but in 5 years, then it's hard to say if you don't give some simulation, some real quantifiable things. Just telling, yeah, in the future you're gonna see the results. Then it's really abstract, and stakeholders that are engaged just don't trust. Like, yeah, you will see. In future, it's gonna be better. It's kind of like a never concrete. So these kind of tools help this process to bring some useful outcomes.
Yeah, and you mentioned information that you would need from this participatory
Yeah,
approach with the stakeholders. What kind of information would you be looking for?
yeah. And at first stages, it's basically flows information,
Mm,
strategic decisions in allocation of resources. That's also one of the, let's say, positive things in this kind of like in this kind of modeling, that I don't get into economic data. I don't care about what's the market price and what's the how much do they pay for the incomes and so on and so on. So I stay into a biophysical level, because then it's also more possible to get the information I need to create in order to create the models I produced. Uh, but this, even when we are not when we're getting into economic data, give us a really precise understanding of what's the actor's behavior, and what are the drivers that trigger the decisions they are taking into the system. Just taking into account the stocks and flows.
mm, yeah, that's so true. And I suppose that we're talking a lot about models. So then, really using participatory modeling approaches and engaging stakeholders into co-creation and knowledge and co-ownership of the model, it really helps to move away from this black box of the model and to have a better understanding, a better transparency of the assumptions that we're making in the model. So indeed. Well, I see there are no more questions, and we're anyway on time. So I would like to thank you again, Manuel, for the time you took, for a very good presentation and a very productive discussion that we had. And I would like to announce that the next seminar will take place in March on Thursday the 25th, and it will be our colleague Florian Dirks. He's a climate change officer at the Federal Climate Change Department in Belgium, and he will present on climate change and material flows, how to design a global circular economy. And with that, if there are no further reflections on this, I thank you for your time and I wish you a good day and see you soon.
Thank you so much, everybody, for being here. And
Thank
see you
you
soon.
for very interesting
Hi everyone.
presentation. Thank
See you soon.
Thank you. See you.
Bye.